Hi, good afternoon, everyone. Sorry to cut into the chit-chat. I hope everyone had a great lunch and no sleeping this afternoon. Just a quick reminder to all. Hello. Hi, good afternoon. I hope everyone's had a great lunch this afternoon. No sleeping's allowed for the rest of the afternoon. There's too many exciting topics we've still got to cover. And it's just a quick reminder to the HCP workers. You do know that you get your CME credits, and you will get a certificate of. Thank you, attendance. I couldn't think of the word. I've had too much to eat. And just a reminder that the CME credits, you will get those. Oh, and that also goes for everyone that's online. So both those that are here in attendance and those that are online, all healthcare professionals can obtain their certificate of attendance for their CMEs. Okay, just a quick reminder. And on that note, I'll pass you on to Merv. Thank you.
Hello. Is this thing working? Hi, good afternoon. Subject we're going to be discussing right now is AI, very much in the news these days and full of exciting possibilities. Subject very close to my heart. Can you not hear me down there? Nope, I guess not. Can you hear me now? Yep, okay, great. Yeah, AI is very much in the news these days. It's a subject very close to my heart. I think there's very, very exciting possibilities for it, and there's also a lot of pitfalls, perhaps. So we hope to expand on that for the next half hour, whatever it is. So, I mean, without further ado, you've met Dr. White, you've met Dr. Miller, and Anne-Marie, and let's get on with it. So, to the panel, I asked the question, how would you define AI in the context of healthcare management? Are we going to start with this slide?
And I'll start by apologizing, because I actually thought that it might be nice just to give basic terminology for AI, just so everybody was on the same page, and then we'll get into the questions. So if this is review, this was totally my idea. It's my fault. You can blame me. So next slide. These are my complex, same as before. Next slide. And then next slide again. Oh. Your slides aren't advancing. You can go to the fourth slide now. So when we talk about artificial intelligence, this slide is going to come up, but really we're talking about anything that is an algorithm that does something that normally you would think that humans do. So this could be like language detection, image detection, classification schemes. So it's actually really broad. It's not necessarily talking about like cyborgs. It's a broad term for any computer algorithm that does something you normally consider to be human intelligence. Next slide. So there's actually many broad categories, but a lot of this boils down to machine learning and deep learning. Machine learning is a lot like those quizzes you do online where you answer 10 questions and it tells you your favorite movie. So a lot of them work on this forest-based method where it has just different classification branches, and uses those branches to divide people into one or two categories. Next slide. Deep learning talks about these multi-layered learning approaches. So this is just a convolutional neural network that I drew out here. But deep learning is this multi-layered learning approach. Next. So what's the benefit of machine learning? So it's efficient at integrating a lot of different information. It really works best with tabular data. Next. The trouble is you have to make sure that you're using good data, or else your machine learning model really can't work. Next. The other thing is it's important to separate training and testing data, and we'll talk more about these two terms. But the trouble is if you try to test on the data that you're training, it just memorizes what the features are. So it can be perfectly classifying the training data if you train it for long enough. So you have to make sure that these training and testing sets are separate. Next. There's no preconceptions about the importance, but the trouble is sometimes it identifies features that seem clinically meaningless, so you have to have some way to interpret this. Next. And that comes down to explainability. So then the last thing is like more of a stats nerd thing. So it's really helpful for dealing with interactions and nonlinearity. But that's, again, stats nerd stuff. Next. So again, when we talk about deep learning, it's this multi-layered learning approach. Next. And it depends on how you build the layers, what the function is. So these are 3 different examples of neural networks. Bottom left, you can see a convolutional autoencoder. So we use this for image denoising. The top right is a convolutional neural network. That's really good for classification tasks. And then the bottom is UNet, which is really common in imaging-based work. But really, it's how you build these layered learning approaches that defines the task. Next. So the benefits of deep learning, you can just look directly at images, whereas again, machine learning uses tabular data. So deep learning just looks at images, looks at data sets. It can identify these latent image features. So these are like the subtle image findings that we think we see, but we can't really put our finger on. And then it has no preconception about the importance. Next. This is sort of important for deep learning, especially in the context of explainability. So this was a deep learning model that was designed to find COVID. And what you can see is actually all the places that it's identifying with the explainability model is outside of the lung. So actually it was identifying like the chest x-ray tags because they had one site with a very high proportion of COVID. And it was identifying things like, is the patient in the ICU? And that's based on where your heart's located. So with deep learning, it's really important to have explainability so that it's actually identifying things that have some plausible meaning that it's important. Next. So just getting into training and testing. So these are different ways to train and test. So on the left is cross-fold validation. This is where you have one data set that you just split multiple different times. You can do repeated cross-testing. So here the blue would be like your training data and the red is your testing data. If you have multiple sites or some other grouping feature, you can also do this repeated external testing where you set out specific groups of patients for testing and specific groups of patients for training. This is really important for AI because when you look at applying these things clinically, the question is like, is this going to apply if you look in new patients, new sets of patients, new sites? So in order to get into that, you really have to look at external testing. How does it perform when you look at new groups of patients? Next slide. The other way to do this is by time. So what we've seen is like amyloid's been changing a lot over time. The other thing that changes over time is cardiac transplant. So this was a study where we looked at training and testing either as this cross-validation where it's randomly split versus temporal validation where it was split by year. Next slide. And what we showed is that when you just did this random cross-testing, it looked great. Those are the dashed curves. But as soon as you did this temporal cross-validation where you actually look at how does this work prospectively, the AUCs were significantly lower. Those are the solid lines. Next. So the last 2 terms that we might talk about here is supervised and unsupervised learning. So supervised learning is where you tell the model what classification task you want it to do. So you, like, does this patient have amyloid? Does this patient not have amyloid? The other way to train a model is not to tell it the specific outcome, but just ask it, what are the features of this data set? So that's unsupervised learning, where you don't give it a specific target, and it just tells you something about the data sets. Both are potentially relevant for amyloid, so they'll probably come up later. Next slide. That's it? Good. Okay, so those are the basic terminology just for our discussion. And now I'll stop interrupting Merv.
So thank you, Dr. Miller. Yeah, so some fascinating insights there as to how AI works. But in all that, how would you define AI in the context of healthcare management?
Yeah, so I mean, really, AI can be applied in a lot of ways. I'm going to try to make it like more AI or amyloid specific. So you could look at it all the way along a patient's journey. So like AI could potentially be applied early for screening patients, identifying patients most likely to have amyloid. Could be applied to classify patients into what type of amyloid do you have, ATTR, AL amyloid. And then it could be applied to like predict outcomes. So how are people going to respond to therapy? Who's going to do the best during long-term follow-up? And then it could be really applied through any of the techniques applied. So earlier today, I showed how you can use AI to automate quantification of pyrophosphate scans. There's certainly AI applications in CMR. So really, it's like as creative as you can be how AI could potentially be applied, but really all the way along the journey.
Right. Yeah, I've played with, I mean, just for example, with ChatGPT, this is quite some time back, and I said, put the questions in. If a patient has this, this, and this, and this, and this, what could the possible cause be? And it just throws up its hands and says, oh, it's very complicated. You need to go to the doctors and ask them. So it was a pretty useless exercise.
Well, I think just extending on both of those comments, I think that when we talk about its application in healthcare, it really is very pluripotent because a lot of the foundational work that's been done in AI doesn't just focus on medical imaging, for example, or medical diagnostics. It's really foundational to all aspects that across multiple industries, we've figured out how to build efficiencies, be able to do flags of errors. We've been able to figure out how to make sure that we track things better. So, I mean, there's so many different applications. I mean, I think that, yes, today probably we'll speak more about medical diagnostics and prediction modeling, but you're going to start to see AI even introducing itself into, booking schedules and things like that in healthcare systems. But you just mentioned a really interesting one, which is large language models. So, we're all familiar with these as ChatGPT, but there's a very rapidly growing interest within the medical community to train specific or targeted large language models that learn from curated data resources, not the internet necessarily. Some of the foundational components of the model may have been trained on larger data sets, but then to actually fine-tune them to specific tasks. And using, for example, a large healthcare system's electronic health data sets, providing context through guidelines, published articles that have been curated, and actually try to refine large language models that when you ask them a question like you just did, actually come back with a very informative answer. And potentially that you can learn patterns within healthcare systems that you can ask specific questions about a patient and say, well, given this test in our healthcare system, what would be the most effective next test for us to do? And actually be able to bring that context forward. So I think that's going to be very interesting. It's also going to be under the largest scrutiny because that's one of the targets of high priority or high risk as far as FDA is concerned, because then it could start to actually influence how we behave as clinicians, which is of a lot of concern.
Yeah, no, I think that's a huge concern, and certainly that's like a theme that's all through AI is, I think physicians want physician oversight. I think most patients want some sort of physician oversight over AI and not just a model that's giving a prediction that we follow like it's the rule. And certainly, again, I think there's many different ways that AI could go, but I think physicians might have different perspectives on this than patients. So actually, this is probably a good question for you, Anne-Marie, which is like, where do you think AI should be going, and like what AI strategies are best applied in amyloidosis, and like is it in management, is it in identification, like where do you feel like from a patient perspective?
I think from a patient perspective it would be absolutely awesome if we could do that from an identification point of view. So for example, a patient comes to see their doctor, their cardiologist, GP, it wouldn't really matter. So say we start at the beginning, say it's the GP, and they come with these various things that are not right with them, and they don't know what's going on. They're having, for example, maybe hypotension, they're having unexplained weight loss, they're starting to feel numbness and tingling in their hands. So if we have different criteria that we could put in, it could raise the possibility. Could this possibly be something like amyloidosis? And it doesn't have to always refer to amyloidosis. This can be for any disease. So as we know, there's something like there's probably over 10,000 different rare diseases out there. No one in their right mind could ever know all of those diseases. However, with the help, I think, of AI, we could perhaps diagnose a lot sooner. And as we all know, in terms of amyloidosis, often many patients had several years before they got a correct diagnosis. In my own case, it was probably around the 8-year mark before I get diagnosis. But we also hear the good side to that too, that some people in the first couple of tests that their doctor's done, they've seen something about it before, or there's a little warning bell, and they get diagnosed within a month or even a couple of weeks, which is awesome. And the second part to your question.
No, I think that was a great answer, which is like, this is what you see as the patient need. And
Yep.
like, I was having a conversation with another patient from Calgary recently, and that was the same theme, which is like, it's hard to put all these various diagnoses and symptoms together, and how do you put it together and sort of improve the screening? Because it's one thing to rely on expert physicians who have seen it before, but it's another thing to have that at a broad scale where it can be applied to all the patients who might not be seeing a physician who's seen a lot of patients with amyloid.
Yeah.
And I think that's definitely a strength of AI, is trying to put together lots of different things that might seem unrelated.
Yeah.
It's a key point that you made, though, is like, it's not just amyloid. How do you tease out all these different diagnoses? And I think that's where it comes down to a lot of how models are trained and tested, and like, how do you actually test it on multi-system classification? And that's something that James has done in his work, and it's certainly a challenging thing to do, but
Sure.
It's something that AI, I think, has a role for.
And I think one of the other things too that's really important here is often in terms of amyloidosis, patients that are often misdiagnosed. And that's through no fault of a GP or any other healthcare professional out there. It's just that amyloidosis is so vague and so complex, and each case that one gets is different, that we can't really point the finger at the medical community and say, well, that was your fault, you misdiagnosed me. No, it wasn't, because it mimics so many other diseases. But therein lies a danger, as we know. And the same when we get a diagnosis of amyloidosis, we have to make sure we know which type are we dealing with. Are we dealing with AL type of amyloidosis? Is it the wild type amyloidosis, or is it the hereditary type, or one of the other really rare types of amyloidosis?
You just actually mentioned something I found interesting, is that you said, well, I wouldn't blame the physician, right? So, one of the challenges that I think we're seeing as far as adoption of AI is that people actually are very quick to blame AI if it gets something wrong. And this actually is an important distinction. Like, it's not necessarily artificial intelligence, it's augmented intelligence. It's supposed to augment your decision, right? And so if the AI gets it wrong, then it will, is the problem, is that there are going to be cases where AI guesses and got it wrong. We shouldn't just discard it. It's just a tool to try to improve our performance. It's not going to be 100% perfect. And one of the things with regulatory clearances right now is that they're holding it to a very, very high bar. And what that bar is shifts constantly. But I do think that everybody should realize that the AI is only as good as you train it, and if you don't have perfect data to train from, it will not reach perfection. And so just something to kind of gauge our expectations.
It was like in the good old days when we started with computers, and of course, I don't have grey hair for nothing, I remember those days, where, what was it we were taught? Garbage in, garbage out.
Right.
So if we put a whole pile of garbage into the AI system, we're obviously not going to get proper results. So we have to know what we're doing and how we're doing it. And like you say, there's going to be high standards in that, which is great.
Computers are dumb.
Of course they are.
They only can tell you what you tell it. No more and no less.
Yeah.
But my little pipe dream is related to what you were saying. Typically, a patient would see 5 or 6 different specialists, none of which talk to each other. It's not their fault. The system is not there for them to do it. So my little pipe dream would be a national database, for example, whereby each doctor could input their findings, and then AI would say, whoa, because of this and this, here's a few potential red flags. you should maybe be looking into this. The other part of that story is the old saying, if you're not looking for something, you're not going to find it. That's where AI, my opinion, would really come into its own.
I think that just leads us to how do you achieve that? And so, one of the things that, I think it is the next question here is, was asking how do you extract information at a personal level? The amount of data that we each contribute as we're passing through our care journey is actually substantial, but we look at it very differently now. So whereas 20 years ago, it was very kind of analog thought, it's like, okay, what was put in the text and what was put in the record? Now, as Rob has been describing, we have the ability now to look at not just a set of images and say, okay, there were 5 images. No, that there was actually thousands of pixels within each image, and the AI has the neural capacity to look at it at that level. I don't, but the AI does. And so now when we think about how much information is available for each patient as they see each of those physicians, well, then we've got their histology, we've got their lab tests, we've got their imaging, we've got their outcomes. If we can standardize those data assets and combine them, then I think we can achieve what you're talking about. But the question is, how do you actually get the data all organized in the same way?
Well, as Anne-Marie says, garbage in, garbage out. Yeah. You've got to have the right information and obviously the right questions. Yeah.
Yeah, and actually, like, data management, like you're talking about, is like a huge issue regardless of the data source for AI. So I work in a couple of different registries where we just collect data once. And even when you collect data once, you still spend months and months and months cleaning it. And James is an expert in managing data, and one task is like, there's a lot of data out there, but filtering through the data using multiple sources of ways to confirm things. So like, if you think of something simple like, does this patient have diabetes? Like, you could look at lab results. Do they have an A1C that suggests they have diabetes? Is there a physician who said they had diabetes? Is there a clinic note somewhere saying they have diabetes? There's many different ways you could try to get this data together. So like, it's another challenge potentially for AI, is like actually cleaning this huge amount of electronic health data to make it clean data, or whether or not you're just making dirty data look clean.
Yeah, and I'll comment on that because I spend most of my time right now trying to deal with these issues. And so, one of the things that I think you'll see is that a shift towards the earlier adoption being of relatively pure data resources. And so rather than, electronic health records are great, but they're one of the dirtiest data sources we have. Okay, they're very heterogeneous, they're not curated, and things find their way into your health record that are not true, unfortunately. But I can't deny that if somebody does, for example, a 12-lead electrocardiogram on you, it's the same data and it's going to be captured the same way, whether you got it done at your GP's office or at a hospital. That's not entirely true, there's caveats to that. But you can see what I'm saying is that it wasn't based on somebody subjectively entering some data. It was just the electrical signals of your heart at that moment. And so what you're seeing is a lot of the early adoption for AI is picking kind of the low-hanging fruit. Let's not deal with all those issues of quality of data. Let's find the data that comes in the purest form and just train from that. It may not be the best algorithm in the world, but it's easy to justify. And same with imaging. We can fairly well standardize how the images are acquired, and we can deal with things if they're slightly different. And so imaging has been another early adopter of AI. But when we start getting to integrating all multi-domain data resources, you're going to see it's going to take longer. And that's because the data coming in is much more challenging to work with.
Yeah, we were in Prague this week earlier, and we saw a presentation by an Italian doctor. And they actually have a system in place already with a national database augmented by AI, whereby kind of the scenario I was mentioning, where each doctor would put his information in and AI would then collate it and say, whoa, here's a problem. So it was quite an eye-opener. So on that note, realistically, as I say, what advances do we need to have for AI to have this real practical utility for amyloidosis in particular?
you want to try to tackle that one first? I have my own personal bias about this, which is like, I think amyloidosis is particularly challenging for AI because it's rare, or at least like in terms of large data sets, it's rare. There's probably a lot more out there that are just unclassified. So this is actually part of the trouble is if you look at a health system level, we just know the patients who were found. We don't know the patients who weren't found. So if there's lots of patients with amyloid within that data set, that causes noise for AI to try to learn it. And then I think the second real major issue is external testing. So most AI algorithms are developed within a single center, and then they test it inside their center, and they say it works. And when you try to apply it externally, it sort of falls apart because data doesn't look quite the same. And images, even though they're standardized, don't look quite the same. So these are two major issues, is like actually the quality of the data that's available, because there's patients with amyloid that are labeled as not amyloid in large data sets, is a problem. And then the availability of large data sets that span multiple centers is really not available in amyloid. There's other potential issues though, James?
Yeah, I mean, I think to get pragmatic use and actually get it into clinical care, the barriers are very, very long. And so it is about, first of all, do I have the right data? Is it going to answer the question that I want? What's the bias within that data? How do I identify that bias and try to remove it? And if I can't remove it, how do I build flags so that I say, you should not use it because we don't actually have people like you in our data set. And so now you shouldn't use it at all. And then when we go to actually implement it, how do we monitor how its performance is doing within the local community? Not out there in the place that invented it, but actually in your hospital. Is it doing what it's supposed to do? And do we have checks and balances to turn it off if it's not? And so these are all things that are plaguing hospital systems right now, because the wave of technology is like a tsunami, but the ability of those health institutions to implement it and monitor it doesn't yet exist. And so like many institutes, we're building a program that's solely devoted to that. It's like, how do we make sure our data assets are standardized according to how that algorithm was trained so that we treat it as a data product? How do we make sure that it worked? And how do we make sure it's going to keep working in the future? Right. And so I think institutions need to put those things in place first, and that's going to take a few years. I think the early adoption can be very straightforward, kind of maybe simple but effective techniques that don't rely on as much complication. So keep algorithms as simple as you possibly can. And that's actually, I think, just another comment, is that we all get excited about trying to make models complex and sophisticated. That's the opposite of what we should be doing right now. We should be trying to build the most simple, explainable things possible. And sometimes it's not even AI. And so that's another thing, is only use AI when you need to. I can come up with a 6 or 7 point risk model that is a totally explainable model. It's based on common statistical methods, and it works. So if that works, and I've got another model that's AI and complex that's getting the same performance, I shouldn't use it. I should use the simple one. And so we shouldn't get fixated that AI is always the right answer.
Yeah, no, I think that's fair. So one other concern or barrier that I'll just open up to everybody here and get their concerns is like identifiable data. So like if you talk about prospectively implementing amyloid screening in electronic health records, people haven't consented to this, to be contacted about, hey, maybe you have amyloid. So there has to be some sort of balance and a way to make it protected. And James, you've done some work in this arena, and certainly your comments would be great. But also, Anne-Marie, how do you feel about people using your data to train models? Because if your data is in electronic health records, people might be using it to look for amyloid. And how would you feel as a patient being approached for maybe you have amyloid in the context of like prospective screening?
For myself, I don't have any issue at all with that. The only issue that I would have is obviously from a privacy point of view. I wouldn't want every Tom, Dick and Harry accessing all my information. However, if it's really only for the healthcare, absolutely that wouldn't be an issue. I think that's something we need to, and it's something I know that we would have in place anyway. It makes sense to me. The other thing that we probably would have to do is to have some kind of standard or set kind of questions to try and ask patients so that we know that everything has been covered. I know, I hear this often, that patients don't want to disclose their information. Well, patients with amyloidosis, if they don't want to disclose their information, they're basically shooting themselves in the foot. Reason being is if we can't collect that information from the patients, how on earth are we ever going to know how many patients have it? How on earth are we going to be able to track it? The other thing that we can track is obviously what therapies patients are on too. So if they're on, for example, on Patro, patisiran, I nearly said Texedi there, but that was the first name, or tafamidis, if they're on any of those medications, any of those therapies, and we know about that, we can track how they're doing, how they're not doing, what age group. There's so much data we can put together that would be so helpful, especially for something, not just, once again, like amyloidosis, but any other rare diseases that are out there too.
Mm-hmm. Yeah. Which leads us direct into the next question is, what do you think are the key concerns with respect to the use of AI and the identification and management of these patients?
Well, there's probably a couple of things to focus on there, but I think first I would say, there are ways to manage healthcare data that does follow proper practice. And so, one of the things that we've been focusing on is how to make sure that we can actually bridge your health data longitudinally over many, many years, but make sure that it's not identifiable to you. And so create a completely anonymized copy of your record, but it's, a 34 alphanumeric code, and nobody would possibly know that that's you. Then it becomes a data resource that can be used by the researchers properly and without any disclosure. But the other aspect of it, I think, is if we actually, I've lost my train of thought. What was the question again?
What do you think are the key concerns with respect to the use of AI? Yeah.
So the other thing I wanted to get to is making sure that we train these big models, because they're very data hungry. They need to see lots and lots and lots of examples in order to make that prediction. So where do we get that data? Well, it can only come from repositories that have large amounts of data. Those tend to be academic facilities in large centers. That tends to mean that the data that's in there does not represent underrepresented minorities, and it doesn't represent the indigenous community. They're getting care elsewhere. And so a lot of the people that need to be identified are never even represented in the data that we have available to train our models. And this is a huge issue, because what we can end up doing is propagating the same bias that's existed over the last 20 years, which is we haven't been getting appropriate care to certain people. And we're going to just propagate that forward. Inadvertently, not intentionally, but we're basically saying how we've practiced for the last 20 years, that's good to train our models, and let's use them moving forward. I think there's a lot of danger in doing that.
Mm-hmm. Yeah, which, I mean, I think you partly addressed the next question as well. How can these concerns be assuaged? How do you get around that?
Yeah, I mean, that's a challenge. So, like, there's the ideal answer, which is you have data that's representative of everybody. That's the ideal. The realistic answer is it's important to evaluate whether or not these things work in other populations. So like external populations, but also ethnic minorities. As we know, like female patients are much less common in the amyloidosis space. Does it really work well in male patients and female patients? Does it span all these different identifiable groups? And that's an important part of the evaluation for any of these things, and really critical before implementing it, or else, as James mentioned, you're really potentially going to cause more harm than good when you implement these things.
Yeah.
I mean, I think that when we do ultimately deploy these models, they need to come with kind of the black box warning at the bottom that says, these are the people that it's been developed in. So if you fit into this group, this is good.
Right.
But if we don't have very good representation for certain patient populations, we suggest that it not be used. And I don't think I see that happening yet. I think everybody's just very excited to get their models published and advertise them. But I think that the regulations will come where that will be necessary.
Yeah. What do they say about angels rush in with fools? Something along those lines.
We have to go.
Yeah. So I mean, what's on the horizon for AI in amyloidosis? Where is this going?
I think it's got nowhere to go but really up, just in terms of the way that we're evolving with AI. And one of the things, as we all know with AI, it can be used for the good or the bad. And we just have to be very, very careful that we don't use it for, well, the health community wouldn't do that anyway, but it's not used for anything sinister or anything untoward. And I believe that's the way that we're going to be going, not just for amyloidosis, but for lots and lots of other things as well. It's an exciting thing.
At a consumer level, that's the Wild West out there. I mean, simple things like I can generate pictures just for the few prompts. It's original artwork. Who has the rights to that artwork? You know, that's a big, huge question mark right now. I can get AI to write me an essay of 200 pages on a subject, and depending on how much information I put into it, will give me a reasonable-looking essay. Is it actually true or not? You wouldn't know.
But it looks good.
That looks great.
I think that's a really important point because, like, I think physicians and patients probably see this very differently. Because, like, if you ask me what's on the horizon, I'd say, well, the things that are really not sexy are what is going to come out. So image segmentation from pyrophosphate scans. Nobody cares who does that. It could be like a medical student who's circling things or AI. Nobody cares, so that's easy to get through the FDA. But then there's a more practical thing, which is like how are patients and patient supports and everybody else involved in the care of patients with amyloidosis using AI? And the realistic answer is people go to ChatGPT and type in, well, what do you think of these symptoms? What's the best treatment? What does this report mean? So I think that's really where healthcare providers and physicians and researchers need to really try to figure out how patients want AI used and sort of work on that process, because you can type those things into ChatGPT and you may not get an answer that's accurate, or you might get an answer that's accurate, but nobody can really tell.
Right,
because
yeah.
if you're going to ChatGPT, it means that you're looking for advice. So I think that's really where there's the greatest need to try to get in front of things, but also where it's the most difficult to make progress.
Right. As I mentioned, just for fun, I just put a whole bunch of symptoms into ChatGPT and said, let's see what this comes up with. And it basically just threw up its hands. I didn't know what to do with it.
Yeah, I mean, I think that's also about, we need to make sure that we're using the tools for the reason that they were designed, right? And because, as I said, I think that we can get to a more informed ChatGPT that's designed to answer your questions. It just was never designed for that purpose.
Right, yeah.
And so, I think as far as what the future holds, you've heard kind of, I think, the whole panel here. We kind of, I don't want you to come away with this with skepticism. We're actually all, I think, really excited about what AI can do. And quite honestly, I'm incrementally blown away every month when I see what colleagues around the world are doing. It completely leapfrogs the next person every time. And so what will we be able to do? I don't think we can actually answer, because quite honestly, it's going to reinvent itself every year. But that being said, I do think that we're going to, at the same time, have to adapt how we use AI so that we don't think that it's telling us the truth every time, and we just recognize it as an assistant to our own decision making. And I think that kind of, it's called physician in the loop. We always kind of say that you need to make sure that AI is not autonomously triggering an action. It needs to first hit a physician before any action can be taken. And these types of things, I think, are now becoming firmly embedded in regulatory processes. And so I think we will control how it's being used. But I think that there's every reason to believe that over the next few years, we will be using AI to make sure that we're capturing more through screening. I think that whether that be from ECGs, from lab work, from electronic health records, I think that will come into practice. And then I do think that Rob and I will be using it more and more every day to be able to analyze our images and make sure that we've done it accurately. And then I do think that we'll actually be getting to the point where AI is actually advancing the therapeutics and the development of therapeutics, whether that's through pharmacogenomics or whether that's through just synthetic, assisting in synthetic creation of drug molecules. AI is going to be in every one of these aspects.
Oh yeah. I mean, you get blown away every day. For example, there's if you go into Zoom, there's an AI add-on to it, which will give you a complete transcript of your meeting, including a summary, who said what, and so on and so on. Just look at this and I think, wow, I could never do that. It's just, it's incredible.
You should teach it to actually understand people with me with a funny accent, because it often gives me some weird and wonderful things. Like, I never said that. Yeah. So there's a funny side to AI as well, which,
Yeah, I think so.
It's awesome.
One of the chief concerns the general public would have is how secure is that data?
Yeah.
What about my privacy?
But as I think it was you that said, James, that we'd probably given like a number, like as opposed to your name being out there, so that all they would have if someone did hack into a system, hopefully they don't ever get that far, would be that number as opposed to the person's name, address, and all that good stuff.
Yeah, no, absolutely. I mean, one of the things that I think is important to recognize is that none of the work that's being done with your data, unless it's being done somewhere else and we don't know about it, none of it is being done with any exposure to any identifying information. Yeah. So, your phone number's not in there, your address, etc. So, but the other thing is that I think institutes are getting a lot wiser as to not distributing data to other external partners as well, but creating these secure environments that other people can come in. And so the data actually doesn't have to leave the server. It's that people are granted secure access to the server to come in, play with it, understand what they need to, and then exit. And so the methods to do this are becoming far more sophisticated.
Which is great.
Yeah.
And it should give the public like that sense of security,
right,
knowing that their data is good. Right. And again, the bottom line is if we're not prepared to share our data, we're not going to find out all the things that we need to find out in terms of the numbers, what type, medications, all of that good stuff. And that would hinder even diagnostically new patients.
So, should we open this to the floor? Any questions out there? I'm sure there are. Just a few.
Yeah, thanks for that fascinating discussion. And it's great to hear the different perspectives from you all up there. So, and I've of course worked closely with James and Rob, but I still consider myself very much a layperson. I have a comment and then a question, I guess. So, the AI revolution reminds me, and I think it is a revolution in many ways, reminds me very much of the omics revolution from maybe 10, 15 years ago with proteomics and genomics and the kind of the explosion of research and the fanfare and the media coverage that this was going to change medicine and reach all corners. And not to say that that was a failure. It certainly was not. And in many ways, that revolution is ongoing, right? And I think a lot of the successes and breakthroughs are not always that visible to the everyday clinician or patient. But it didn't live up to its hype. And in many ways, how could it, right? Medicine is so diverse that how could something touch every corner of medicine and change it? And so there are a lot of parallels there. I wonder if you could comment on that. And you both talked about some of the barriers as well. I guess my question part of this, in addition to just the overall momentum of this revolution, is the barrier that I see as just a regular clinician is implementation, and I mean, you both touched on it before. You know, healthcare in Canada is generally administered by large monolithic organizations that are full of managers and bureaucrats, and or it's delivered in community clinics, right? And so how does something get into that environment to really become a standard of care? So on that easy question, what do you think?
I have opinions about this because I have opinions about everything. So AI needs to have some clear clinical value really to be implemented. And I think where we have like clear evidence that AI has changed how we do things is actually in cardiac CT. So there's various deep learning programs that can interpret coronary CTA and give a report to physicians. And that's really taken off in the States. And it's to the point where if you're using it, you can do about twice as many studies. So from an institution perspective, they're more than happy to pay for this because they're making lots of money off the coronary CTA. And it means patients get more care just because it's more available. And physicians are tasked with trying to like sort through these reports that are generated by AI and making sure that they're actually the truth to make sure they're still in the loop. And the underlying need there was it can take an hour to read a coronary CTA, whereas deep learning can do it in a couple seconds. And then reviewing the report is much quicker. So like there was a clear clinical need, there was an AI application that met that need that was highly accurate, and there was a market for it. So when you have those three things, you see that things can get really implemented very quickly. Like you mentioned, the Canadian market is very different. So we don't make money off of doing more healthcare. So in general, the government isn't really pushing these types of initiatives. And as we've seen, like that same approach hasn't translated at all in Canada. But I think it does show you the things you need to see clinical implementation really take off. Is if you have this combination of clinical value with a need, with a product that works well, things can really take off. So again, I think simple things like calcium scoring is easy for deep learning to do, and I shouldn't have to do it. Quantifying CMR, quantifying PYPs, these are things that deep learning can do that it saves time, and as long as it's not costly, it's beneficial. Screening is going to be a whole different cost-value relationship, especially in Canada, where if you find patients, it generates more cost for the government, even though we know there's clinical value and need. So it's whether or not that whole equation can be aligned.
Yeah, no, I think you've hit it on the nose right there, is that the incentives need to be there, and they have to align with the agenda of the organization that's paying for it. And in the US, there's a very capitalist approach to, does it make money, then it'll get done. And even though their priority is healthcare, but they are organizations that make money. In Canada, it's a very different economic environment. And so trying to convince the authorities to actually fund these things is very challenging. And I think that we will have later adoption. And I think the types of things that we adopt or are funded through the health authorities is going to be different than what you see in the US. That being said, it doesn't mean to say that we can't implement them. It just means that we're going to have to get a lot more creative in how to fund them. Yeah.
Bank robberies comes to mind, yeah. Bank robberies come to mind. Bank robberies.
Oh, bank robberies, yeah. No, we can probably we'll use AI to launder money. Yeah.
So one of the challenges, I think, also is breaking the barriers down between the end users, so us as amyloid, interested clinician researchers. I'm also a myeloma doc, and we have, our own challenges with generating national level data. But how do you think we can move that discussion to ensure that that data is safely, but still very readily available to the clinician researchers? Because right now, I mean, I work in BC now, but I spent 10 years in Alberta, so I know those administrative hurdles. How do you try and get through to the data custodians that it's okay to just give me this data when I want it? I know that may sound a bit too crass, but that is ultimately what we all want. Like when I have a good idea at 2 in the morning and I wake up and I write it down, and the next day I should be able to just go and access that data. But right now that would be a 3-month endeavor easily just to get the first wave of data uncleaned, right? So how do we do that within the system?
Yeah, I mean, I think that that's actually my job in Southern Alberta, is to do that. And I can tell you that as you said, it's an insurmountable job. And so what we've managed to do is over a long period of time, gain the trust of the health organization and try to convince them that this actually is not going to interfere with their agenda, and that actually ultimately downstream it will actually help their agenda. And so we've managed to form a program to basically take that over from them, because a lot of these requests have gone to the data analytics groups of hospitals, and quite honestly, that's not their job. I mean, their job is to facilitate secondary use of data, yes, but really more for administrative purposes. And so you need to create separate groups that are funded differently, that their agenda is secondary use for innovation. And I think that there's a number of groups across Canada that have actually successfully achieved that, but they're small pockets. Fortunately, those groups are starting to talk to each other as well, and so we are creating more of a pan-Canadian effort. But the key thing is that the health authorities won't do it, and they'll put up barriers to do it. So you're absolutely right, and I know that BC is very challenging, for data access as well. But all I can say is, if you champion it and you get an institute or 2 or 3 to come together, there has been success across Canada, a number of institutes.
Question over there somewhere.
Yeah, so I had a 2-part question. Given that AI requires large volumes of data as well as high quality data, so the first part is, do you see risk in using generalized generative AI like ChatGPT for specific use cases like medical or identifying? Should they not be using AIs that are built using specific data for that specific use case? And then second, for the advancement of AI specific to this, are the regulatory barriers and the industry secrecy hurting the advancement of research in this specific area?
Yeah, two interesting questions. The first, I'll try to tackle, and probably James will have comments about both as well. So certainly if you're just looking at a single task, like if you want to say, well, does this patient have ATTR amyloid, it's better to have like a specific use case in terms of your training and testing, because you'll have the best accuracy for that specific question. But just hearing from patients, it sounds like really the ask from the clinical perspective is, well, you have to be able to identify more than just one rare disease. And I think this comes up a lot when people are looking at different applications, is if you look at the training and testing, it's like normals and amyloid patients, but it's not, can you differentiate amyloid from Fabry's, from HCM, from sarcoid, from human chromatosis, from like 1,000 different things that could be there. So I think there's roles for both, and certainly in terms of testing and just proving the hypothesis for one specific question, like specific use case makes sense. But when it comes to clinical use, it's going to have to be like more generalizable. The second question was, does secrecy and regulatory barriers slow down AI? Certainly. I think everybody has to be incentivized to work on this from a commercial perspective, and in that context, intellectual property becomes like a core tenet to what you're working on, and it's difficult to share those things. And I think that does slow down the field, but I think in general it also creates competition, and competition forces people to try to work faster and harder and get ahead. So I think in terms of the clinical implementation, it's really been commercial entities that have had the most success in terms of clinical implementation. So I think even though it might slow down the pure science of things, I think it probably promotes clinical adoption.
Yeah, it's a very interesting topic because there's the whole field of open science, which is really trying to promote everything should be open, right? If you've got a discovery, get it out there, give them the raw code, let somebody else advance it and move it on. And that's fantastic. And it's a concept that I think we all try to adopt whenever we can. The trouble is, as Rob said, is that open science may accelerate the field of research and discovery, but it won't lead to clinical implementation. Why? Because there has to be some monetary reward for somebody to pick it up and say, I'm going to take this through FDA, which is going to cost me X millions of dollars. I'm going to do the validation work, and I'm going to get it approved and bring it to market. And the hospitals won't use it until it's actually a product that's been FDA approved. And so there's this always conflict between, do we adopt an open science philosophy, or do we try to say this actually has legs, this could change the lives of patients, should it go for technology transfer into a commercial pathway? And there's no easy answer. And what most of us try to do is maintain a balance so that we're feeding the open science community, but also when that one thing comes along that you think this one actually could make an impact clinically, maybe we should talk to the technology transfer office and see if it's valid. But it's a really challenging debate. I hope that gave some insight.
We have time for one more question, and there's one on the virtual platform here. So the question is, there are constraints to using AI, you mentioned, but for me as a patient, what worries me is the processing and security of my data. We know that not all hospitals are equal in protecting patient data. They are vulnerable institutions both internally and externally in terms of the information they convey on a daily basis. How does the future face this phenomenon?
Yeah, I think it's an interesting question, and realistically, it's beyond just AI. Like the whole field of having electronic health records means that you have to have a secure way to keep that data accessible to clinicians and accessible to the patients, but also protected from outside people that might want to use the data for a purpose outside of what it's supposed to be used for. So I think it is highly relevant for AI, and as James mentioned, federated learning is one way to do this, where you keep the data within a secure environment and people can use it for specific research questions or processes, and they don't get to access any of the identifiable data, and no data actually leaves. But I think it's really applicable even beyond AI. It's like we really do have to be very careful with how any health record data is being used, whether it's with AI or conventional statistics or any approach.
Yeah, one that was very much in the news a little while ago was the 23andMe debacle. They got hacked. They were supposedly super secure. Right. Okay.
I think there was another question. Ryan?
Was it?
It's all in there.
Alan's cutting us off.
Oh, okay.
I think that was the wrap it up.
Okay, well, I think that about wraps it up. Thank you.
Thank you, everyone.
Thank you all.